Hello and welcome. Thank you for joining us for this year's Virtual Vision series. I'm Will Telford, Senior Product Owner for Usd and Rigging. In this session, you'll be hearing about open source and open standards and how Autodesk is supporting and embracing these technologies. First, I'll be doing a deep dive into Maya USD, our open source USD integration in Maya. Next, you'll be hearing from Nicola and Bernard about the latest on MaterialX. After that, our technology lead for color science, Doug Walker, will be giving you a first look at OpenColorIO version 2, which just debuted at Virtual SIGGRAPH this year. But first, I'd like to give you a brief overview of Autodesk's open source projects. Autodesk is proud to be talking to you today about open source as a strong supporter. We haven't always been the open standards proponent that we are today. We've long employed proprietary technology, but we acknowledge the challenges our customers face in using heterogeneous pipelines. We're happy to say that starting about 5 years ago, we shifted our priorities to embrace and invest heavily in open standards to the benefit of our customers and ourselves. At the time, we didn't even have the legal framework to allow us to support and contribute to open source projects. We had, of course, submitted bug fixes to projects that we used, but contributing valuable IP to open source projects or even launching our own projects was an uphill battle. In some cases, it was actually a two-way street. We had to earn the trust of the open source community in order for them to trust the motives of the contributions we made to their projects. But today, 5 years later, we can point to a large collection of open source projects that we support. Among them, OpenColorIO version 2, which Doug Walker will be discussing today, MaterialX, which Nicola and Bernard will be discussing, USD, and MyUSD, which was started by Pixar and Animal Logic, but now is hosted, maintained, and actively developed by Autodesk, along with the support of many studios. We've even launched our own open source projects like AnimX, which allows anyone to evaluate curves using the logic that Maya does, ShaderX, Softimage to Arnold, and Standard Surface. So as part of our investment in open source, we support the Academy Software Foundation, which has been set up to improve the quality and quantity of contributions to the industry's open source software base. It provides a neutral forum to help drive the growth, adoption, and support of key open source projects that we all depend on in production. So as premier members of the Academy Software Foundation, our investment goes beyond just funding. We also provide technical expertise with our Director of Engineering at Autodesk, Dr. Eric Bork, sitting on the Academy Software Foundation's governing board, and Autodesk Senior Software Architect Gordon Bradley, serving on the Academy Software Foundation's Technical Advisory Council. With that said, we're excited to bring today's topics to you. To illustrate our commitment to open standards, we'll go ahead and get into our next three talks on Maya USD, MaterialX, and OpenColorIO. So please stick around to hear all of them. They'll be great talks. I'll go ahead and kick it off with a deep dive into Maya USD. Thank you for logging on to join us for this year's Virtual Vision series. We know everybody's schedules are a bit precarious with a lot of working from home, so we definitely appreciate your time. In this talk, we'll be covering Autodesk's native USD integration in Maya. I'm Will Telford, Senior Product Owner for USD and Rigging. I'm glad you're here because we have a lot of great stuff to show off today. I'll first give a little refresher on USD for those of you who don't yet eat, sleep, and drink it. But if you'd like an even deeper dive into the history of USD and Maya, please watch last year's Vision series we gave alongside Pixar, Animal Logic, and NVIDIA. In addition to that recording, there's also 2 blog posts on USD and Maya on the Autodesk area blogs that you can check out. So by now, most people know what USD is and how it benefits production pipelines across VFX, animation, and gaming. We know production data sets are growing ever larger. We know more and more people are trying to collaborate on the same data sets across disciplines and even studios. And we know production pipelines need to be more flexible in supporting nonlinear workflows. To date, Pixar's open source USD project is by far the most promising technology to address all of those issues in an open standard. USD at its simplest provides a file format that can represent geometry caches and time-sampled data. This piece of the puzzle enables incremental adoption by serving as a substitute for Alembic, FBX, or other proprietary formats you might employ. But more than that, USD is actually an extensible common language and composition engine for 3D data. When I say composition engine, that speaks to one of the fundamental building blocks of USD, which is composition arcs. Composition arcs are operators that allow USD's rich compositions. Among these operations are the reference and payload composition arcs. USD is built on a robust file referencing architecture. There's the sublayer composition arc, which is how USD leverages a powerful system of non-destructive sparse overrides. The variant composition arc provides support for the definition of complex variations. The variant system is unopinionated though, so the user is capable of leveraging it to represent, among other things, LODs, versions, artistic variations, and different data representations. The final two composition arcs are inherits and specializes, which are two nuanced ways to define inheritance in USD datasets. USD composes these arcs to produce a lightweight, highly optimized scene graph. A studio can actually reduce a lot of the complexity of their pipeline code base by delegating some of that logic to USD itself. And finally, USD ships with Hydra, which is effectively a translation layer that allows any implemented scene delegate to be rendered by any implemented render delegate. For a deeper dive into the finer details around USD itself, make sure and visit Pixar's extremely thorough USD documentation. I threw the web address up on the screen there for you to visit. So that brings us to Maya USD, which is Maya's USD plugin. So there have been several different USD integrations for Maya to date, which has led to some confusion about which one is right for you to build your studio's workflows on. To ease that confusion, we partnered with Pixar, Animal Logic, and Luma Pictures to merge all of their Maya USD repositories into one GitHub-hosted, Autodesk-maintained repository. We are all working towards the goal of making Maya USD the only plugin you need for USD in Maya. While it's in development though, the other plugins remain available in our repository for those who may need them. And they've actually picked up a few new features thanks to the refactored common framework they share with the Maya USD plugin. But keep in mind, everything I demoed today is the official Autodesk Maya USD plugin. The GitHub repository was announced and made public at last year's Vision Series and remains the place to go for Maya USD. This project is the Maya team's first open source project, and all development is being done out in the open on GitHub. From this site, you can download and compile Maya USD, Luma's Maya to Hydra, as well as Pixar and Animal Logic's USD plugins. If you don't have the development resources to compile Maya USD, you will also see that we've provided a Maya 2020 Maya USD installer available for download in the releases section on GitHub. Much progress has been made in the last year, but I'd like to restate our overall vision for Maya USD. We want to make Maya the best place for production studios to create, edit, work in, work with, and collaborate on USD data. The way we're achieving that is by making sure USD in Maya feels natural and native. With Maya USD, we're working hard to integrate all of USD's functionality through its analog in the Maya UI. This means we want you to manipulate using standard Maya manipulators. You should be able to view the hierarchy of USD scene graph right alongside Maya data in the outliner. Viewing and editing USD data directly in Maya's attribute editor, but it also means extending Maya with new UIs that introduce USD concepts new to Maya, like with an all-new Usd Layer Editor. As we mentioned earlier, we want to work with you in the open on getting this plugin right. Lastly, we want to focus on the things that you can't do. Now, this means that we need to make changes in Maya's APIs to support the functionality that you need in the Maya USD plugin. We're accomplishing that through a collection of new APIs referred to as UFE, which stands for Universal Front End. UFE version 1.0 shipped with Maya 2019 and Maya 20, bringing some support for USD to those versions of Maya. We are currently developing and expanding UFE 2.0 to accommodate even more features, which I'll be demoing today. The big win with UFE is that we aren't teaching Maya how to work with USD, but rather we've abstractly taught Maya how to work with foreign data models via UFE. This means that if you have proprietary data models that you want to view, manipulate, see in the outliner, and edit in the attribute editor, you can look at the open source Maya USD plugin as an example and leverage the same UFE API that we do for a native Maya experience with your proprietary data. Now, Maya as a DCC supports many workflows across all disciplines. USD is an entirely new data model that supports much of the same concepts as Maya, as well as introduce some new paradigms. When you put these two things together, you can see how a full-featured native integration is a gargantuan task, and we have to start somewhere. So it's kind of like they say, how do you eat an elephant? One bite at a time, right? So our first bite for Maya USD is assembly and layout. To us, though, assembly and layout doesn't just mean supporting artists in the assembly and layout process, but it's about the generation of the model libraries and the downstream consumption and use of those sets and layouts throughout the production pipeline. It wouldn't be very productive if your animators couldn't animate in a shot with a USD set in it. So today we're going to walk you through the process of viewing USD data in Maya, and then we're going to get into the authoring process where we'll see how to create a model, then create a set, and last how to edit a layout. So a great place to start is with viewing USD data, but the very first thing we need to do is load the plugins. So first we can load Maya USD. And then for switching render delegates later, we'll also load Maya to Hydra. Now that that's done, Pixar has kindly provided several data sets, the most well-known being the Pixar Kitchen. To load that asset into Maya, we simply go to Maya's Create menu, down to a new section labeled Universal Scene Description, and select Stage from File. Doing this will provide you with a file dialog allowing you to select USD files, like files with the extension USD, USDA, USDC, and USDZ. It also provides a prim path to bring in, and prim paths to exclude if you would like to limit what data is read. You can further prune the stage by choosing not to load payloads at this time for heavy data sets. The first thing you'll notice is the extremely fast load times. USD is a highly optimized format, and we're constantly benchmarking our performance to that of USD View. You'll see in our outliner loading the kitchen set has produced a proxy shape. In Maya USD, we use the proxy shape node to identify and visualize the contents of the stage. Stages are one of the basic concepts of USD. You can think of a stage as the container and memory of the composed scene graph. Here you can see that I'm loading a second stage, the Autodesk kitchen set. Each proxy shape here points at one stage. You're allowed to create many proxy shapes in one Maya scene if your workflow requires it. So you can see USD definitely presents huge performance gains over Maya's native data model in a lot of scenarios, particularly in file loading. Over the last few release cycles of Maya, we've actually been pushing hard on the performance with an eye towards load times. So just prior to USD, this chart shows you kind of the progress that we've made over the releases. So unfortunately, we don't have the permission to show the data set that this chart is based on, but you can rest assured that this is a real-world production scene in use in an extremely popular AAA game. And the numbers are actually staggering when you start looking at them. So back in 2017, opening this data set in Maya 2017 took 1 hour and 18 minutes just to open this file. Each release since, we've been improving on those times. So you can see in 2018, that scene's load time went down to 20 minutes. And in 2019, we got it down to 6 minutes. So this is the kind of torture test that we're trying to put Maya through. Now, we did an experiment recently. We took their scene and we converted it to USD. And when we converted it to USD, we got the load time down to 3 seconds. So that's a pretty stark contrast to their original 2017 load time of 1 hour and 18 minutes. So you don't have to take my word for it on the data set. One of my colleagues, Guillaume Laforge, created a data set to stress the system. He made it from Pixar kitchen set assets. You'll notice there are 6,231 objects in this data set, and that loaded instantaneously. Now, these are not the kitchen asset objects. These are actually proxy shapes. So if we want to see how long it would take to load the renderable asset itself, we can turn off the proxy shape and turn on the render shape. You'll notice that that loaded instantaneously as well. So now you can see this is made up of many, many toasters and clocks and cords, pitchers, plates, all sorts of items from that Pixar kitchen. So this doesn't seem to be stressing the system too much, so let's try to push it a little further. So I'm gonna go ahead and hide this object just like any other Maya shape. And I'll come back in here and you'll notice we have another one. This one has 138,000 objects and change. Let's create that. Wow, okay, so those proxies loaded extremely fast, less than a second. But again, it's just the proxy capsule. So we'll test this one and I'll count to see how long it takes for the render to load. 1,000, 2, 1,000, 3, okay, 2.5 seconds. And what we have here is, I believe, what was it, 130 something thousand and change of the same kitchen assets. So this is quite impressive performance, regardless of what these assets are. So the way we found these gains in Maya is by focusing on several key areas. So first, around Maya 2016, we made a really strong push to try to fully leverage your CPUs. So we have the evaluation manager, multi-threading, and visibility evaluator, and the performance profiler are all there to try to make better use of your CPU. In Maya releases 2017 through 2018, we focus more on GPU acceleration. So 2016, we're focusing on CPU. 2017, 2018, we're focusing on GPU. So with GPU, we rolled out GPU accelerated deformers, the dynamics evaluator, custom evaluators, and GPU APIs, as well as the evaluation toolkit. So now we've accounted for CPU, we've accounted for GPU, so now we wanted to go after your RAM. So in Maya 2019 and 2020, we focused on utilizing RAM more efficiently. So with that, we brought along features like background evaluation and efficient bidirectional caching. So now that we've fully leveraged your hardware, with USD, what we're doing is we're now turning our attention to the data model itself and making sure that users can make the right choice so they can leverage the right tool for the job. There are cases where USD's data model is going to present advantages to you. There's cases where Maya's data model is going to present advantages to you. But we leave that to you to make that decision on when and where you're going to leverage these different technologies. Now that we have the proxy shape in Maya, we're able to render the USD stage in the Maya's VP2 viewport. To do this, we've created a VP2 Hydra render delegate. This means that you should be able to use other foreign data models besides USD if they have a scene delegate implemented. So beyond the load times I spoke about earlier, our emphasis on performance has also benefited us in other key areas. So snapping with large scenes is actually 5,000% faster. That's not a typo, it's actually 5,000%. So in addition to that, we also see that object selection is now up to 100% faster. Isolate select is also up to 50% faster. And you can see that moving vertices on large meshes is up to 350% faster. In addition to that, we also have component selection, which is up to 250% faster. So with Hydra or with USD utilizing our VP2 Hydra render delegate, it gets to benefit from many of those same performance gains. But actually, this is kind of a two-way street, because in the process of developing MyUSD, we've actually had to make changes and improvements to VP2 itself that will actually feedback and improve Maya's performance on the native Maya data model, even when you're not using USD in your scene. This is most evident in our material consolidation work. where we've seen big gains by actually consolidating materials to reduce the number of draw calls in your scene. Having access to VP2 now means that we have access to VP2's functionality, like wireframe mode, smooth wireframe, bounding box view, X-ray view. You can toggle default materials, screen space ambient occlusion, we have access to wireframe on shaded mode and multi-sample anti-aliasing. It brings light support, shadow support, and depth of field as well as motion blur. We've also added selection mask support that works across data models. We've included support for framing in the viewport. And with VP2 support, Maya and USD data models can coexist in the same scene, allowing them to influence each other's VP2 effects. So with Maya to Hydra loaded, the viewport's Hydra render delegate can be switched at runtime. Here we can see Maya using Pixar's USD View's native GL renderer, Storm. So the next bit of UI that's critical to viewing USD data in Maya is the outliner. To the left of the viewport here, you can see Maya's native outliner. You'll notice that if I expand out the proxy shape, you can see the USD scene graph hierarchy right in Maya's native outliner. Along with that, you'll see that selection is synced from the viewport to the outliner. The outliner will show us icons for different USD data types. Deleting in Maya will set a prim's active state to false. We will then see the active state of prims indicated in the outliner. Using Maya's show and hide will gray out the prim in the outliner view while affecting its viewport visibility. And composition arc badges will provide a quick at-a-glance view of prims that have authored composition arcs on them. In addition to the outliner, we have also made Maya's attribute editor UFE aware. With it, users are able to directly view and edit USD attributes in the Maya attribute editor. Maya's attribute editor maps all known USD parameter types to their corresponding Maya widget for display. Okay, on to authoring. So where do you get started if you don't have a kitchen set or really any USD data? That brings us to our first category of assembly and layout workflows, creating a model. This is where we do data translation or import-export. We can start in Maya with a textured Maya model. We want to export this model to USD on disk. This is done using the same native workflows you always use for export in Maya. We go to the File menu and we choose Export All in the File dialog that pops up. Make sure we choose USD Export for the files of type. Doing this presents the user with several options. They can choose ASCII or binary for the ambiguous USD extension, select a new parent scope that can be created for the exported data. Users can choose their subdivision method and whether to export color sets and UV sets. The user is able to choose how material export is handled. They can choose none to not export materials, display colors, or convert materials to USD preview surface. Lastly, the material export is pluggable. so third-party plugins can register their own material translation on export. Exporting the USD file gives us a USD file ingestible in any USD-supported software. Here we're checking our results in USD view. We can also load the same file back into Maya as a stage to check it there as well. If we want to edit this model further, we're able to import the USD data back into Maya following standard Maya import techniques. So you go to File, Import. In the presented file dialog, we make sure we set the files of type to USD import. The USD import options are seen under File Type Specific options. You want to make sure to select a USD file on disk to see the Scope and Variant section. This section provides our hierarchy view used for doing a selective import, where you can choose what prims are and aren't imported, as well as select what variant you would like to import. Back in the file dialog, you will see that you can easily reset the import back to the entire file by pressing the reset icon. Material options similar to the export gives you a choice on how to map the USD preview surface shaders to a selection of Maya material nodes. Standard surface, Lambert, Blend, and Phong are available, as well as a new USD preview surface material node for lossless translation. This has taken USD data on disk and imported it as Maya data in memory. From here, we can edit the model as we would with any Maya scene, and then re-export back to USD. We can also compare side by side the original Maya model, the imported Maya model, and the USD model read in as a stage. Using Maya, we can now create and export USD models to populate a library of USD files for assembly to pull from. The next step in enabling assembly and layout is creating a set. In this step, we will create a new stage from scratch and then populate it from our library on disk. So this can be done by going to Maya's Create menu and again down to the Universal Scene Description submenu. But this time, we're going to select Stage with New Layer. The outliner shows us that a new proxy shape has been created named Stage 1. This means we have a stage, but no prims exist yet. We can go ahead and create our first prim by right-clicking the Stage Shape 1 node, choosing Add New Prim, and selecting Xform. A new prim now exists in our stage named Xform 1. You'll notice that you could have also created an undefined def, a scope, or one of USD's geometric primitives. To assemble our own kitchen set, we first want to rename our new prim. This is done using Maya's native approach by double-clicking on the name in the outliner. We are then able to type kitchen set. We can repeat this process to build out the scene graph how we would like. In the process, we can reparent outliner objects and duplicate them as well. When we're ready to start pulling models from our library, we can create a prim of type def. We plan to add a reference to this prim, so we leave its type as def so it doesn't redefine the prim that it's going to reference in. Right-clicking on the prim, we can click on Add Reference, which will bring up a file dialog, allowing us to select one of our models. Again, we can repeat this process to finish assembling our set. Now we just need to save our changes to disk. We already have a USD stage in memory, so we don't need to export it. The stage we created was created from a new anonymous layer. Anonymous layers in USD are in-memory layers that aren't backed by files. To convert the root layer to a file-backed layer, we just use the new Usd Layer Editor. We can launch the layer editor in one of two ways. First, right-clicking on any prim or its proxy shape in the outliner, you'll see the first entry is Usd Layer Editor. Or it can be launched from the main Maya menu under Windows General Editors. At the top of the layer editor, you'll notice it allows you to switch context between any existing proxy shapes in the scene. In the main editor, you can see our root layer is Anonymous Layer 1. It has an orange dot next to it to indicate that it has unsaved changes in memory. By double-clicking its name, a file dialog comes up that allows us to specify a file name to write out the layer name changes. And the orange dot will go away. We can then verify our results by loading the stage back into a clean session of Maya. We just created our first set, but there's much more the layer editor we'll cover in a bit. So the final phase of assembly and layout is enabling artists to lay out a set. Continuing on with our layer editor, it's capable of much more than just converting anonymous root layers to file-backed layers. The layer editor represents the root layer stack, which is made up of sublayers. Sublayers are one of USD's composition arcs. Unlike the other composition arcs, which are defined on prims, sublayers are composed on other layers. They apply to the entire stage. The MyUSD Layer Editor embraces the use of anonymous layers, as it allows the user to experiment without creating files all over the system. It also helps with speed, as the user is able to defer decisions about their intent and how a layer is supposed to be used until the moment it becomes necessary to make that decision. So, for instance, if a user wanted to create a shot layer structure that's laid out in the same way that the Pixar USD glossary example is for sublayers, that can be done in the following way. So first, we create a stage from scratch. Now, with the root layer highlighted, we can quickly add 6 layers. Shift selecting the final 3 layers and then dragging them onto the layer above them gives us the exact structure we need. Now that we have the structure we want, we can begin to convert the anonymous layers to file-backed. This is the same process we followed before by double-clicking on the name and giving it a file to write to. Now let's say we wanted to set up our shot to bring in our kitchen set on the sequence dressing layer. You'll notice that at the moment we're targeting our edits to the root layer, shot.usd, as indicated by the blue target next to its name. We instead would like to route our edits to sequence dressing.usd. To switch, all we need to do is select the target circle next to sequence dressing. We can now reference in our kitchen set, the same way we built it in the outliner. Right-click on the stage to add a new undefined prim. Double-click it in the outliner to rename it to kitchen, and now we can right-click on kitchen to add a reference. Select the kitchen.usda file we made when we created a set, and now we've set up the sequence. We can use this layer to add any other models we would like to dress the set with. For sequence level layout, an artist can now choose to target the sequence layout layer. Edits made to this layer are stored sparsely and composited over the layers below them. Now would be a good time to talk about the type of edits we can make. UFE has enabled support for parenting, renaming, duplicating in the outliner. It also has enabled support for manipulation in the viewport. Along with manipulation, we also have snapping supported between the different data models. Parameters can be viewed and edited in the attribute editor as well. To make viewport selection more friendly, we've also added selection by kind. Kind is a type of metadata that USD attaches to prims to define a higher level categorization. By default, viewport selection will select the lowest leaf node prim that it hits. Through selection by kind, we can specify that we want to select a model instead, or even by group or assembly. This makes it much easier to make sure you're putting your edits on the right prims. Returning to the layer editor, there are a few more features for inspecting and debugging your scene. Save edits for that sublayer only. Discard edits, which will remove any in-memory changes, restoring the file to its state on disk. Clear, which will empty the layer entirely. Remove. Add parent layer, which will add a layer above the current layer. And print to script editor, which is a fantastic way to debug the contents of your layer. You'll notice that each sublayer has a no symbol on the far right. This indicates if a layer is muted or not. Muting a layer removes its effects from the composition. By muting our sequence layout sublayer, we can see our composition has returned to its sequence stressing state. Sometimes studios need to set up dependencies between data. Our current work contains the architecture for a way to drive USD data with DG connections and to extract data from USD to drive Maya data through DG connections. Here is a lighting example that shows a USD teapot that is driving a Maya spotlight. I can move the Maya spotlight around, but it will follow the teapot whenever it is moved. If we take a look at the node editor, we can see that there's a DG level connection that pulls a matrix out of the USD stage and drives it into the new offset parent matrix attribute that we have on all Maya transforms now. So hopefully you should now have a pretty good idea of where MyUSD is and where it's headed. We're extremely excited with its potential and we're investing heavily in it. This work is just the beginning of it. Our efforts continue as we begin to explore authoring of other composition arcs, as well as shot-based animation and in-context workflows. Like I said back in the beginning of this talk, Maya has a very large surface area as a DCC, and as a data model, USD does as well. Getting here wasn't easy. It took the blood, sweat, and tears of a very large team at Autodesk, as well as in the open source community. So everything I just demoed was a tremendous amount of work. I'm just the lucky guy who gets to stand in front of you and present it. So remember, since MyUSD is an open source project, your participation is welcomed and encouraged. So please come find us on GitHub. I'll also be around at the end of this session with the other speakers for Q&A. So thank you for giving me so much of your time to cover all of this material with you. And make sure to stay here for our next presentation. Coming right up, we have Nicola and Bernard to present all of our progress on MaterialX. Thanks.
In this section, Nicola and I will present an update on MaterialX. We will first provide the motivation behind MaterialX, as well as a brief introduction. Next, we will look back on the last year before looking at future work on MaterialX. Lastly, we will provide an update on LookDevX. The primary motivation is data interoperability of material assets. Within the film and VFX industry, assets need to be shared between various studios and vendors. There can be a heterogeneous environment with incompatible interchange between various tools and renders. Without a standard, it is difficult to avoid lossy interchange, and thus it is hard to achieve repeatability of the look for complex assets. It becomes additionally more difficult if the asset needs to be deployed to both real-time and offline renders. Naturally, this interoperability problem exists in other domains, including design and AEC. Customers such as IKEA and WSP have given feedback to such effect. For those that are not familiar with MaterialX, we will provide a short introduction. MaterialX is an open standard which allows transport of material assets. It supports both patterns and texture networks, as well as graphs for layered, physically based materials. Additionally, material assignments and looks, as well as management of look variations, is supported. MaterialX started as a project within Lucasfilm in 2012 to address the growing need to transport assets between teams and applications, as well as for archiving them for future reuse. The first production to utilize MaterialX was Star Wars: The Force Awakens. Within Autodesk, at roughly the same time, we had a project called AMG, which had similar goals. After discussions with Lucasfilm in 2016, we decided to join forces and collaborate on a single open standard. The results of this collaboration resulted in the first open source release in 2017. Our continuing contributions include a close collaboration with Lucasfilm on the specification and implementation of the core API, contributing the shader generation framework, which makes it possible to transform the MaterialX description into code targeting specific renders, and a specification for a standard set of physically based shading nodes. In addition to just patterns and textures, shading models can also be described in a portable way. Using this library, it is possible to express industry-standard shading models, such as Autodesk Standard Surface. Ongoing development work can be found in the Autodesk fork of MaterialX. We now take a look at updates since last year. During the year, we have contributed to the release of a second revision of the 1.37 specification. Additionally, we have been working closely with Lucasfilm on the draft specification for 1.38. We encourage those that are interested to have a look at the proposal, which is now online. We will now go over some key updates. To support AEC and manufacturing industries, physical unit support was added to MaterialX. This allows inputs, including images, and the quantities they represent, such as displacement, to be specified at an absolute real-world size. Both the core API and shader generation support conversion to the target scene units of the application. Shown here are a few examples of Autodesk Materials using units for input patterns. In 1.37, there's a separation in implementation between node inputs and parameters. The main difference is that parameters can only take on uniform values. Having separate implementations for parameters is an annoyance, leading to code duplication when performing node traversal. For 1.38, nearly all parameters have been changed to be inputs, since there is no reason to have the uniform value restriction. The additional simplification is that all parameters, which still need to be specified as a uniform, can be specified as inputs, but use a new uniform attribute. For 1.37, materials are specified using special material elements with shader refs and bind inputs. For 1.38, materials are now just regular nodes with regular inputs connecting to shader nodes. The advantages include the ability to use the standard API to connect nodes and inputs and to perform node graph traversal. The removal of special case functions such as getJaderFs and getBindParams. And the ability to define arbitrary material output nodes. To aid the creation of definitions, new APIs have been added. This includes support for creation of node defs from node graphs and the ability to selectively publish inputs and output interfaces. An example of a node graph implementation for a definition is shown at the top. On the bottom is an instance of that definition along with its associated resources. APIs for sampling specific inputs or subgraphs are recent additions. This has allowed for utilities such as wedge rendering and texture baking to be supported. Here we show wedge rendering used as a diagnostic tool to see variations in appearance over a change in specular anisotropy. The texture baking example bakes upstream graphs into image nodes, making the overall graph more easily consumable for real-time integrations while maintaining appearance. In addition to access from MaterialX View, support in Python is in progress. Updates to BSDF nodes support has improved the fidelity for rendering with GLSL. Multiple scattering is now taken into account in the microfacet BRDF evaluation, compensating for energy that previously would be lost for rough surfaces. Implementations have been added for some of the more advanced BSDFs in the physically based node library. This includes supports for sheen, for the backscattering effect of cloth-like materials, and thin film for rainbow-like iridescence effects. It is possible to preview these using wedge rendering as shown here. There is now a new way to describe vertical layering. Instead of nesting BSDF nodes, as shown on the left image, we now have a layering operator node that connects the two BSDFs involved in the layering. This is intended to provide a more flexible and consistent setup for users. This year we started a collaboration with NVIDIA to add support for MDL, or Material Definition Language, to our shading generation framework. This means that an application that can consume MDL can now easily support MaterialX as well. For more information on this work, please see the joint presentation from GTC earlier this year. In this example on rendering, we show a comparison between rendering using Arnold with OSL on the top and iRay and MDL on the bottom. And in this slide, we show another visual comparison, including rasterization in MaterialX View. From left to right, we have iRay using MDL, Arnold using OSL, and MaterialX View using GLSL. We now take a look at future work. A target goal is to be able to create libraries of shared definitions for general usage. The aim is to support definitions with arbitrary categorizations, where such definitions can be from any content provider. Future work includes open sourcing content examples, working at library guidelines and asset packaging, and looking more closely at light definitions. We are also using this to create the upcoming Autodesk Material Library, a new material library based on standard surface and MaterialX. It is designed to provide consistent visuals for materials across the full suite of Autodesk tools. This includes not only media and entertainment packages like Maya and 3ds Max, but also architecture and design applications like Revit and Inventor. We are continuing to work with Adobe to enhance the interchange of MaterialX assets via the MaterialX plugin, which was released earlier this year for Substance Designer. Additionally, we are continuing to collaborate on enhancements to the MaterialX specification and implementation. Support for 3ds Max is still in the early stages. Interchange of MaterialX documents as well as usage of OSL shader generation are the current targets. For shader generation, we have been concentrating on node graph flattening utilities and generation of OSL reference implementations. For content creation in Maya and rendering using Arnold, the target is to use the LookDevX component. For general Arnold support, some important areas to address include rendering of shader graphs that use a mix of OSL code generation and Arnold custom nodes, and also support for custom node definitions and displacement shaders. For real-time rendering, we have been looking at enhancements to shader generation. To tackle implementation portability and to ease the burden of maintaining numerous backends, we have decided to use SpearV for cross-compilation. The first backend targets will be for rasterizers before looking at ray tracing support. The sample images shown here are some early results. Note that integration of such shaders is covered in a companion Vision Series session. Moving beyond desktop, we have been looking into support for web deployment. This support can be broken down into two parts. The first is JavaScript bindings for MaterialX libraries. The aim is to provide wrappers which are equivalent to the current Python bindings. Work has started for MaterialX Core and MaterialX Format modules. The snapshot shows a working example of node graph creation using JavaScript. The second part is support for WebGL code generation. The aim is to complete both parts to allow deployment to targets such as 3.js and the Autodesk Forge Viewer. An early result is shown on the right. We're excited about a recent project from Pixar, which takes a first step towards integrating MaterialX into USD Hydra. For the HD PRMan render delegate shown here, in this initial prototype, OSL code generation is used for pattern graphs, connecting to RenderMan terminal or material nodes. This approach is similar to that used by Substance Designer in Arnold, mixing code-generated shaders with terminal nodes. Here's another example from Pixar rendering MaterialX materials in HD PRMan. Future work includes adding support for HD Storm or OpenGL delegate, pattern baking into textures or PTEX for OSL generated code, and handling of more MaterialX features like custom node defs, displacement, and volume shaders. Within MaterialX, there exists a framework for adding color management support. Support for a basic set of input color space transforms is currently provided as part of the MaterialX distribution. We are interested to start a collaboration which will target support for OpenColorIO version 2. More details on Ocio will be given in the next talk. LookDevX is an initiative that we've been working on to address the following user workflows: interactive node graph and definition creation, interactive material and look creation with the ability to integrate with a DCC for material assignment and scene-dependent inputs, interoperability with any tool or render which supports MaterialX. It is currently an inner source project with the intent that it become a collaborative effort. The target is to provide a set of reusable modules, some of which can be open sourced. Nicola will now cover LookDevX in detail.
So LookDevX is native editor of MaterialX standard library. It's integrated Maya as a plugin, built as a component so it can be shared with other Autodesk products like 2ds Max in the same capacity as we are developing it for Maya. Bifrost users can feel at home with LookDevX Graph just because our graph solution VNN is built again as a shareable component. In the future, LookDevX will replace Hypershade. One-way material transition will be offered to users, and you're not going to be able to use Hypershade and LookDevX at the same time in scene. As we can see an example, Arnold is supporting MaterialX standard library through OSL, and obviously their team is essential in supporting our efforts on multiple complex fields. I guess this is good enough for the high-level introduction, so let's dive in current state of LookDevX in Maya. Classical node collapse view options are introduced using 1, 2, 3 shortcuts globally. or per node, as you can see. We added auto layout node shortcut. You could change the look of connection shapes. And as you can already notice, we can render swatches now. More about swatching features coming very soon in our updates. Highlighting connection on selected node. So you select node, you can see connections, how it's been highlighted. Selecting upstream node, downstream nodes, or selecting it on both directions, that's introduced. Obviously, this could be very, very handy if you want to create backdrop for selection. Naming your backdrop accordingly, that's very handy. Zooming in and out of graph would automatically change node views. Cutting connections sometimes can be very useful. Then connecting selected nodes using C as a shortcut. Auto-connecting nodes using drag and drop, finally we have this. And if you delete nodes, we will try to keep connections alive. Adding new nodes through tab search would automatically connect new nodes to selected nodes.
For example, let's say you don't like our color correction shader definition just because he has too many attributes. Let's build now, just for the example, simplified color correction shader definition node. With standard library, pretty much you can create any kind of type of the shader. In this case, contrast, multiply, saturate will be good enough for our example. So let's select our nodes and hit Ctrl-G to create compound. Now we need to get into the compound and start outering our nodes. Creating input and output connections, it's first thing. But the next thing is to promote attributes to the top of the compound and then outer their names. Final step of our process is to publishing our custom shader definition. Since I would use this color correction node all the time, I will publish it under the global category, but you can publish anywhere. You can create your own category. And this is kind of handy, or quite handy, when you start searching for the nodes. So let's go back to the graph, and now we can add instance of our simplified color correction shader definition node. Let's select whole material graph and create compound. Then I will promote attributes I think users will take advantage in their look dev and lighting workflows. Idea is to make sure that they don't need to look into the huge list of the nodes we've seen here and connections. Again, next thing is to alter our material UI. Then we will publish our generic parquet material to our library. In this case, it will automatically be assigned to material category. And that's it. We have to just repeat this many times. Okay, let's use our published parquet material and check how it's going to render. First, we will need to create material assign node that will be used to establish a connection between material and geometry. Then we need to create collection node that it will be used to define list of the geometry that will be using our material. And finally, we need a look node. Currently, look is not used in his design capacity, so please check MaterialX spec and follow us on Maya beta regarding better understanding exactly what is the look capacity and how far we're going to push. Now we need to define a list of geometry and to add it to collection. You could just select geo and add it to collection, or you can write expressions since collections are fully procedural. You can pre-build any kind of selection that you want to add it into collection. So let's hit Arnold render button and check our work. I'm going to adjust some promoted attributes, and that works well. I'm going to continue creating generic materials and saving them to our library, hoping that anyone can easily use them in their project. Or our next step, where we're going to start adding those materials to the scene. All assets in this scene are referenced. The only floor asset is not looked at. Please notice how the full gray shader is assigned to the floor geometry. So let's open Maya scene with the floor asset where we can start initial look development. Scene is pre-built with lighting and the full shader is assigned to the asset. My first step is to search our material library for potentially good kitchen floor material. So let's start with generic Parquetto tree we just published. So we're going to connect material to material input under the material assign node. And then we're going to render using Arnold. So it looks quite good, but I need to adjust UV tiles since published per kit scale will probably not fit kitchen scale. Additionally, adjusting displacement scale, saturation for diffuse texture, and then I'm going to start rendering again. Yeah, I guess I'm happy with the initial results, and I'm sure we can improve it later in the master look dev scene. I'm going to experiment with a few more materials and prepare them for the master look dev scene. Idea is to leave them in a scene as additional variation of the floor material. In short future, this workflow will be pushed to the next level usability and pipeline friendliness by using looks. Currently, we need to switch material variations manually. Setting parquet to a 3 as a default floor material. And then I'm going to version up Maya scene to 0006.
As expected, the default material is still assigned to floor asset. So let's reference our version up scene with new materials. It's going to be version 06. Loading the scene, and there you go. Our scene is updated. So yes, LookDevX is supporting Maya referencing. Parquet 3 is already assigned and ready for Arnold to render. I gotta speed up recording here. Yeah. Anyway, since we have a few other materials available in reference graph, we could check how our scene will look with floor material variations. Again, current workflow regarding using multiple material variations in one graph is work in progress, so exciting updates are coming very soon. So let's export fridge material graph to 3D Max. Zap, material is yours.
Importing the fridge into Max, everything come in as physical materials and OSL shaders. This makes them work in the viewport and the rendering. Here I'm rendering it in Arnold. We can see the subtle bumps, but I'm not a big fan of the bumps. I'm going to get rid of those. I want to make a metal fridge, add some roughness, turn on the metalness. Yeah, red is not my color. So I'm going to use psychedelic noise. Okay, that's a little too psychedelic. Subtle, yes, but too small variations. So I'll bring in a position and a divider and connect it, set some values, and yes, looks like heat-treated metal. Good enough. Now I want to use the MaterialX logo. So I drop in an image node, and I need to split that out into a color, and I connect this. Yeah, nice, but I want it on top of the other. So I split out the alpha, and I add a mix node. I connect the alpha as the mask, and boom, our color on top of the metal. But I want it to look like vinyl wrap, so I will invert the alpha and put it as metalness. There we go. Vinyl wrap MaterialX fridge, rendering it in Arnold, looking fantastic. Gonna export this for Nicola to use. And before doing that, a quick test render in V-Ray as well. Yep, OSL and physical works in V-Ray, so works just fine there. I'm gonna export this to the MaterialX viewer and test it. Yep, material works there too. Okay, Nicola, here's your material. Enjoy.
Thank you, Zap. So let's import MaterialX file that is authored in 3D Studio Max. Please notice that imported graph is described using MaterialX standard library nodes. Rendering it in Arnold, and we're gonna get exactly the same results we got it in 3D Studio Max. Okay, moving to Substance Interop. We asked David Larson and his team to add a little bit more proceduralism to our brick shader. David, floor is yours.
So here we're looking at a Substance Designer material where we're going to give a set of scanned images some superpowers using MaterialX. So we start with the scanned bitmaps, and then we do a bunch of image processing in Substance Designer. And we create a set of textures here. So we have like a detail map, we have a mask for the different tiles, and a roughness map, and we're referring to them using these usages. So these usages can be picked up by a MaterialX graph. We're switching to a selection visualization, and you can see the maps, how they're coming into the MaterialX graph here. And since we're working with MaterialX here, we're going to give it shader procedural superpowers. So we have basically built a graph that allows us to control various aspects, such as the color variation per tile. We can also control the color of the different, the general color of the tiles. And we can overlay dirt. So these are shader procedural. So if we go into the MaterialX view application, we can actually tweak these afterwards. So we have only one set of textures, but we can still get many looks.
And for the end, loading MaterialX file output by Substance team in Designer. Slightly different graph organization, but it's supported by LuxX. And let's do the first pass in Arnold, finding better lighting spot so we can see better material patterns, adjusting dirt and brick color variation, and as expected, quite nicely done procedural brick by Substance team. This is pretty much the end. Thank you for your time. In a fairly short time period, we will expose LuxX at Maya Beta to pretty much select a group of the customers. So if you're interested to be part of creating software of your choice, please contact me. Thanks again for being part of the 2020 Vision Series.
Thank you, Bernard and Nicola. Now we're going to take a look at the work Autodesk has been doing on OpenColorIO. I'm Doug Walker, Technology Lead for Color Science at Autodesk, and I'm also serving as the Chief Architect on the OpenColorIO Technical Steering Committee. OpenColorIO is an open source color management library for creating and displaying consistent images across multiple content creation applications during visual effects and animation production. It provides four main capabilities: a configuration file or config file for documenting the color pipeline that will be used on a specific show, a loose set of user interface conventions for accessing color management from within applications, the ability to read many of the lookup table or LUT formats used in the industry, and pixel conversion engines for both the CPU and GPU. Ocio was introduced 10 years ago and has become a de facto standard for implementing color management in the industry. It's been integrated into Maya, Arnold, and dozens of other applications. It's also been identified as the ideal color management for other open source efforts such as Usd and MaterialX. OCIO is used on virtually every major VFX-oriented film, and it's become the preferred method for productions to push the color pipeline for a large show out to all of the VFX subcontractors that may be working on it. Despite the success, it's also faced challenges over the course of its development, and it's worth spending a moment to talk about some of the challenges associated with open source. Open source software is now pervasive. When we stream a film from Netflix in the evening to relax, we're relying on open source software. Likewise, when Disney or Universal puts a frame of a new movie in their archives as an ACES file, they're also relying on open source software. You could almost think of open source software libraries as the roads and bridges and content creation applications like Maya and Flame as being the cars that drive on them and that we rely on to take us where we want to go. They've become critical infrastructure. That infrastructure needs to constantly be modernized and updated to keep pace. But since the software is free, open source projects sometimes struggle to find people to do that work. OpenColorIO and several other projects such as OpenEXR and OpenVDB were all wrestling with this problem several years ago. For example, OpenColorIO did not have a single release between 2013 and 2017. At that point in 2017, Autodesk reached out to Sony Pictures Imageworks, the studio that developed OpenColorIO, and offered to help. We collaborated on a proposal for a version 2 of OpenColorIO and presented it to the community at SIGGRAPH of that year. The proposal was warmly received, and on that basis, Autodesk spun up a team of 3 developers to work on implementing it, consisting of myself, Patrick O'Doul, who's the lead developer, and Bernard Lefebvre. In parallel, Autodesk was participating with the leading VFX and animation studios in conversations around how to nurture and support these libraries that we all depend on. This resulted in the creation of the Academy Software Foundation, or ASWF, in September of 2018. The ASWF was developed in partnership with the Linux Foundation and provides a neutral forum for developers to collaborate. Autodesk was one of the founding members and participates at the Premier level, which is the highest funding level. In addition to providing funds, each Premier member agrees to commit 1 full-time developer. Autodesk well surpasses that, with 3 currently on OpenColorIO v2, not even counting the other projects you've just heard about. In February of 2019, OpenColorIO became the second project accepted into the Academy Software Foundation, and a technical steering committee was elected and is chaired by Michael Dolan of Epic Games and has representatives from all the major studios. There are now also 5 other projects in the ASWF, all of which having a similar governance model. Now let's talk about some of the new features in OCIO v2. One of the many changes in the industry over the past 10 years is the use of GPUs for rendering final frames. Although OpenColorIO had some support for GPUs, it was essentially a draft mode that was not equivalent to the CPU. For OpenColorIO v2, we've completely re-engineered the GPU renderer so that it may now be used to render final frames. OCIO provides a flexible processing model that consists of a pipeline of mathematical operators. The config author may combine these in arbitrary order and direction to build a chain of arbitrary length. In OCIO v1, the CPU rendering engine evaluated the chain of operators precisely, but the GPU rendering engine converted the operator pipeline into an approximate form that placed fewer demands on the GPU. In OpenColorIO v2, the GPU renderer has been completely replaced with one that implements all of the operators and is able to process pixels exactly as the CPU does. This image shows the results of testing done at Sony Pictures ImageWorks using their ItView review tool to apply an ACES output transform. The result on the lower right shows an amplified difference image between the CPU result and the OCIO v1 GPU result, which indicates significant error. The result on the upper right shows the same comparison using the OCIO v2 GPU renderer, with the black image indicating a precise match to the CPU. ACES, the Academy Color Encoding System, is another key open source color project for our industry. The way I think about the differences between the projects is that ACES is the what and OCIO is the how. In other words, the ACES project is working on specifying what the color spaces should be and defining the transformations between them. OCIO is working on how to make those color spaces and transforms available to users of VFX applications and on how to apply them in a very accurate and performant manner. Autodesk has also been a major supporter of the ACES project for many years. In fact, the first use of ACES on a film or television project back in 2011 was done in close collaboration with one of our customers. Autodesk has also made contributions to the core ACES transforms and was an early adopter of the Academy ASC Common Lud Format. Many of the people that encounter ACES in visual effects do so through the excellent OCIO config for ACES. That config works very well, but there are some edge cases where it runs into trouble due to some fundamental limitations of 3D LUTs. In OCIO v2, dedicated operators have been added so that the ACES output transforms can now be implemented without 3D LUTs, and this allows the transforms to remain faithful over a much wider exposure range. This is leveraging technology that was originally developed for Flame and Maya. Another ACES-related feature is full support for the Academy ASC Common LUT format, which was one of the main components of the recent ACES 1.2 release. The Common LUT format, or CLF, is similar to OCIO in that it provides a set of basic color operator building blocks that may be stacked together in order to accurately implement arbitrary color transforms. Unlike most other LUT formats, it's designed from the start to handle floating point data and may easily accept scene linear color spaces as input, which is something that other LUT formats struggle with. Because of this capability to accept and produce ACES 2065-1 color space, it's the ideal format for representing ACES look transforms and is also designed to work well with the new ACES metadata format. In addition, because it's very well documented and now has an open source implementation with a thorough set of unit tests, it's well suited to become an archival standard. Another aspect of the ACES config that we've worked to improve is that it currently requires hundreds of megabytes of LUT files. As other standards such as USD and MaterialX look to implement color management, we'd like to help them adopt the ACES config as the preferred default. For example, if no other config is specified, it would be ideal if USD and MaterialX files could use the ACES color spaces by default. It's also worth noting that even in cases today where a production does not use the ACES config itself, they quite often use that config as a starting point, and reuse many of the components. So we've added the notion of built-in transforms to OpenColorIO v2. This means that the ACES config and other configs involving standard color spaces could be implemented without requiring any external LUT files. If the entire config goes from hundreds of megabytes down to a few kilobytes, it becomes much more friendly to workflows that need to be self-contained with as few external dependencies as possible. This is an issue for many use cases, such as cloud applications. Another new feature that is relevant to USD and MaterialX is the ability to convert between different configuration files. In Ocio v1, each config file defined its own self-contained but isolated color universe, and there was no way to convert between two configs. For example, if you had an asset from an earlier production that you want to use in a new show, there was no guaranteed way to do that. The new feature allows config authors to define a standard interchange role that ensures it will always be possible to convert any of its color spaces into another config that also uses that role. One area of color management that is often problematic is monitor calibration. At the high end, there are monitors such as those from ISO that are able to perform internal hardware calibration. But sometimes people are not able to afford a monitor like that, or they're on a laptop. In those situations, people often assume their display is calibrated to sRGB. However, wide gamut monitors are now commonplace as display vendors aim at gamuts such as DCI-P3 or Adobe RGB. And so the assumption that all displays are sRGB is becoming less and less true. In these cases, the best approach is to leverage the ICC profile that is available for the monitor. And ICC is the prevailing standard for color managing displays on both Mac and Windows. Both of these operating systems are able to provide a profile for each connected display. In OCIO v2, a config author may define a special virtual display to take advantage of the ICC profile of a user's monitor and to specify exactly how it will be used. This opens up the option of emulating in OCIO what a user may be seeing in Windows from other applications that are based on ICC color management, while still enjoying OCIO's advantages, such as its ability to easily deal with wide-range scene linear values. Color management is a confusing subject for many people, and the proliferation of color spaces over recent years has exacerbated that. For example, the popular ACES OCIO config has over 300 color spaces, and this can create some pretty overwhelming application menus. A lot of the new v2 features are intended to help config authors and application developers provide a better user experience for artists. For example, it's now possible to hide color spaces, group them into hierarchical menus, and filter them based on category. In addition, the file rules system from Maya that provides flexible options for assigning a color space based on the file path has been extended and added to OCIO v2. Also, the viewing rules from Flame that allow applications to know which view transforms are most appropriate for a given color space have also been added. Many other improvements have been made to the core OCIO processing infrastructure. Various optimizations have made applying common color conversions up to 20 times faster. Also, all color transforms may now be inverted, including 3D LUTs. OCIO has a feature called context variables that is often used by config authors as a way of supporting shot-based variations. For example, a look transform that varies per shot could be represented by a context variable called $shot. This is a very flexible system, but it also presents challenges for applications that want to play back a timeline consisting of multiple shots. We've made many enhancements to the underlying architecture to help facilitate this. For example, we've added a new caching system that is intelligent about knowing what context variables affect a given transformation. The work we did extended beyond just adding cool new features. We take seriously the fact that this library is an important piece of infrastructure that many people depend on. That's why we increased the number of unit tests in the codebase by a factor of 10x to over 1,000 tests. The new continuous integration system checks all new code on 10 Linux configurations, 5 Mac configurations, and 5 Windows configurations. In addition, Ocio now has the ability to run GPU unit tests and compare the results against the CPU results. All of this means that as additional development occurs on the library after V2, that there are many checks in place to try and prevent bugs before they get introduced. We feel that this will dramatically improve the robustness and reliability of the library going forward. We hope that provides you with a good overview of the work we've done. We also wrote a paper for DigiPro this year that goes into more detail on the new features if you'd like to learn more. This has been a rewarding 3-year journey for Patrick, Bernard, and myself. We're proud to have been able to take the lead in rejuvenating this important part of the VFX industry's shared infrastructure, and to be able to open source some cutting-edge technology developed for Flame and Maya in the process. That concludes our session, The Source Awakens. We hope you've enjoyed this look at some of the open source projects that Autodesk is contributing to. Thanks for watching. We'll now move on to the Q&A.
Thanks, Doug. That was awesome. We've got a lot of questions coming in on the Q&A, so I guess we can just jump right into it. So first up was USD, so I will take a quick look here to see what questions we have around USD. So one of the questions is there an API for USD or for Maya USD? And so what I'll say is when we're using that proxy shape, the answer to that question is a simple yes. When we're using the proxy shape, it is just a pointer in Maya to a USD stage in memory. So it's actually USD data. And using UFE, you can get a pointer to that USD data, and from there you can use the native USD Python APIs to work with that USD data as if you weren't even in Maya. So there is an API, and you can completely manipulate that data from the USD API. So I'll go from there. I'll hop into a LookDevX question. So one of the LookDevX questions coming in is, will LookDevX be released as a standalone or parallel with the Maya beta integration?
I can take that one. LookDevX is going to be released as a Maya implementation for now. There's obviously plans to possibly implement LookDevX even for Macs. This is still to be determined. So there's not going to be a standalone version of the LookDevX, at least for now. That's the plan, and that's the way how we're going to go for sure in the next foreseeable future. If I can pick next two questions quickly. How do you plan to list all materials in the scene? Outliner, separate manager. I think we need both. Regarding the outliner, it's going to be pretty much as we have right now in Maya. But we definitely need separate manager of materials and overall shared definitions. And the last question regarding LookDevX is, are we going to make it more modern attribute editor? Yes. So attribute editor right now is still in progress. We are working on modernizing all widgets there. And those widgets that we're going to add there actually is going to come up from the Bifrost team, and we will just implement it in the LookDevX team. So important to know, like I said just right now, so the whole graph is actually shared between the components, and we can actually improve it in a really drastic way. Thank you.
Cool. All right. It looks like we have a question here on MaterialX. And there's a question here, does MaterialX have a translator to Unreal Engine?
So there isn't specifically a translator. There's work being done between Pixar and Epic right now. So that's a new project. And probably you can get more information if you follow that project. So there isn't specifically a translator per se.
Okay. And let's see, I'll hop back to another USD question. There are questions around release and why doesn't Maya USD ship with Maya? Questions along those lines. And so, as I mentioned in the presentation, Maya USD is a plugin. And what that allows us to do is it allows us to decouple from Maya's release cycle, which means that we can release more frequently. It also, it's not only is it just a plugin, but it's an open source plugin, which means that all of our work is actually out in the open in GitHub right now. So as I was saying towards the beginning of the presentation, you can go to GitHub, you can download the code, you can compile it yourself, and you can have Maya USD as it currently exists. For those that don't have those resources, There is also a release section on GitHub. GitHub kind of buries it a little. It's a very small label off to the side that says releases, but there you'll also find an installer that's a precompiled version of MyUSD that will install against Maya 2020. The only way in which we are coupled to Maya is through those UFE APIs I was talking about, whereas UFE API version 1.0 is what you'll find in Maya 2019 and 2020. We're currently in progress on UFE 2.0. So not everything I demoed today can be done in Maya 2020, but the strengths of Maya 2020, the import-export functionality, where you're translating from USD data on disk to Maya data in memory, or translating from Maya data in memory to USD data on disk, that is all possible in 2020 and 2019 with what's in the current GitHub repository. And so also, because we're a plugin, there's nothing that prevents us from shipping a plugin alongside Maya. There's a lot of plugins that ship with Maya. So we want to get this to a state where it could be packaged with Maya, and that's kind of our goal. But again, current development is all out there and available right now. Looks like we have an OCIO question. So here's one for you. Do you see OCIO being the default color space in Maya in the near future?
Interesting question. The nice thing about OpenColorIO is that it does not mandate specific color spaces. So what Ocio allows is for the technical staff at a studio to define the set of color spaces that they want to appear in Maya and other applications, and that can change from production to production. Now we will ship some default configs for people to use with Maya that will be a superset of what's available now in Maya. So for people who don't have like a color scientist at their facility or a technical person who's going to author a config, there will be a good collection of color spaces to use. And there is also the ACES config that is also very well suited for people who are kind of looking for recommendations of what color spaces are the best to use.
Great. And I'll tack one more question on here because I think it's a quick one. But somebody, you had mentioned a white paper at the end of your talk. They were saying, what is the name of the white paper that you'd mentioned at the end?
Right. We prepared a paper for DigiPro this year. The name of the paper is "The ASWF Takes OpenColorIO to the Next Level." It goes into more detail about the new features and the motivation and sort of the things that we were thinking about as we designed the new set of features. This will also be, in addition to being available at the ACM digital library, it will also be published on the OpenColorIO website soon. So that's opencolorio.org.
Great. Okay, so a question coming in for USD, which I'll go ahead and take. There's a question around USD and 3D Studio Max. It says, is USD for 3D Studio Max going to be implemented similar to Maya? I think USD is a better communication way between Max and Maya than Syn to Max Maya. So the Max team has their own vision series, and I think I'll let them speak about that. But what I can talk about is the fact that, Autodesk is really pushing open standards and really standing behind open standards. And USD is a big investment, not just for Maya, but for all of Autodesk. And so there is collaboration where we're doing cross-application testing between Maya and Max. And you can see that Arnold has their own USD implementation, which they've open sourced already as well. We have other projects where the Shotgun team, we've partnered up with them and we've looked at ideas around USD-based reference pipelines, where we have participants in industry groups that are looking at asset structure organization for, say, archival purposes and things like that, all leveraging USD. So there are a lot of USD projects between our different software packages that are all tied together in a way. And the U in USD is for universal, right? So it's very important that we have interop. So yes, we feel that this is a very strong format for interop, and whether that's Maya and Max, or whether it's Maya and Arnold, it is a strong interop that we're investing heavily in. So let me go ahead and hop. Oh, looks like we got another OpenColorIO question coming in. Let's see. So are you planning to implement some gamut compensation algorithms into OCIO version 2? Would be helpful to mitigate some ACES related color issues when working with plates converted to ACES CG going into negative pixel values.
Yeah, it's an interesting question. This is actually a topic that the ACES group is investigating right now, and there's an active working group that's chaired by Carol Payne of Netflix and Matthias Scharfenberg from ILM, and they are meeting regularly. So if you go to acescentral.com, you can get the meeting invite for that to join if you'd like. Once they have a recommended algorithm, we do plan to add that to OpenColorIO. I don't know if it will be in time for V2, but yeah, that is definitely something on our radar.
Great. Okay. Nicola, I have another one for you. You answered a few extra questions. Did you already answer the question around procedural noise?
No, I didn't, but
okay. Yeah. I can fill that one to you. I can send that one to you. It's with LookDevX, is there any plan for procedural noise patterns and filters?
Yeah, that's a great question, Rashid, and I appreciate that question. So not just those three, obviously, as you mentioned, like there's much more. So we definitely want to support patterns, and it's this is coming very soon because LookDevX is set, and the whole workflow is set to actually create all kinds of types of patterns. And yeah, if I can say a quick answer, yes, and much more.
So
okay, great.
I can add a little bit to that, I guess. So actually, the standard library that ships with MaterialX already comes with noise. So that noise implementation is actually based on the Sony OSL one. And Lucasfilm has also contributed Worley noise as well. So actually, there's actually a lot of kind of image processing nodes that are already in there, because initially MaterialX was for basically compositing. So if you kind of take a look in the standard library, there's stuff that's already there. So you can already do some proceduralisms. So maybe take a look there and see if there's, something else that's not quite there. It isn't that hard to actually add new definitions, and that's what we're looking at, is to either allow us or allow other people to add definitions as they want, and then build procedural graphs.
So I've got a few more USD questions here. I see that a bunch of questions are coming in that I haven't had a chance to filter. So while I'm answering this next USD question, I don't know if anyone wants to dig through those and see if there's any more MaterialX, LookDevX, or OCIO questions that we can ask. But I'll go ahead and answer this USD one, which is, how does the USD exporter handle custom node types? Does it require a custom USD plugin? Would you get partial data out if you don't have that? So there's several ways to interpret this. If you're talking about Maya custom nodes and how would you export them to USD data, the MyUSD plugin supports custom translators. So if you had a custom node that you needed to export in a certain way, you could register a translator with MyUSD to export that. Other than that, if it's derived from a transform, it'll probably export as a simple transform. Coming at it from a different interpretation, if we have unknown schemas that you've implemented, proprietary schemas on the USD side that MyUSD knows nothing about, I guess there's the question of how would that work? And for import, it would be the same thing, where you would need to register your own custom translator with the MyUSD plugin. Again, like I said, it's pluggable. Our plugin is pluggable. So you could register your own custom translator with that, so they would know how to bring in a custom schema and map it into my data type. And then thirdly, if you take that same interpretation of a custom schema, but you want to bring it into a proxy shape in Maya, and you want to keep it as USD data in memory, what that would mean is, right now, what MyUSD would do is it supports it completely. It'll bring it in because it's just a USD stage in memory. What would happen is that schema would represent a prim. It would come in. You would see that prim represented in the outliner. All of its parameters would show up in the attribute editor, or at least all the parameters that map to known Maya data types with known Maya widgets would show up in the attribute editor. But what it wouldn't do, it wouldn't draw on the viewport because Maya doesn't know what it is. But if you read that in, if you modified that stage and you saved it out, it would be non-destructive to that foreign schema that MyUSD doesn't know about. So it should handle it well if you're working with custom schemas. And if you're like I said, if you're working with Maya custom nodes, then you would need to write your own translator for the export to know what to do with that. Export or import, right? It wouldn't know what to do with that data. So it would be lossy for unknown Maya node types unless you wrote that translator. Did we find any extra? Oh, it looks like LookDevX grew a little bit here. Let's see. Was there a certain question here, Nicola, you had your eye on?
I'm just typing on the side. One answer.
Okay. All right. Let's see. I see it was mentioned LookDevX will be looking for limited beta testers. Is this limited to studios, or may individual users reach out to request to the beta user of LookDevX? If individual users can reach out to request to the beta tester, how can we apply?
Yeah, the beta is going to be open, obviously, for everyone. We're not going to just choose studios. Obviously, there's lots of individual testers who are awesome, have time and have knowledge and experience to help us to build this software for you. We will definitely go with the limited space from the beginning. So we're going to have like smaller, concentrated team that can just help us to move faster out of this foundation portion of the LookDevX that we are right now. So you can email me directly. I will just try to facilitate this later. So we're going to contact you later and just set up this core team first. And then slowly, when we are ready to get LookDevX to the whole beta community, then we can actually deliver that later. So I will just put my name there, my email there.
Okay, great. And looks like we got another question for Doug. And this one's a bit abstract, so I guess you can come out however you want. With OCIO V2 out the door, what is next? I guess vacation. I don't know.
Yeah, it's been a busy summer for sure. Well, the library is now ready for developers to start integrating into applications. So we're working on adding it to Maya. We know other application developers are also working on adding it to their applications.
Uh-oh, did we, I don't hear audio. Is that me? Did we lose Doug?
Yes.
Okay, all right. Doug, I think your audio cut out there for a bit. So I think we'll move on to another question. Let us know if you get your sound back. Let's see here. We talked about custom nodes. Let's see. There's a question here about MyUSD integration, whether we already support the export of MaterialX in USD exports. No, we don't currently support MaterialX export. That's kind of coming in hot to USD itself. We are a big proponent of MaterialX. That's why we presented here today. So our plan is to adopt that and integrate it once it's well supported within USD itself. We'll get there. Now, as you did see, we do have material support. So when we export materials, we export them as a USD shade preview surface into USD itself. So when you're bringing them back in, you have the option to map those to be, well, you have the option to not bring the materials. Two, you have the option to bring them into a new preview surface material node we have in Maya that will render the same as preview surface, or you can bring them in a standard surface, or we've even thrown in our legacy one. So if you, for some reason, wanted to bring in all your materials mapped to Lambert or Fong, you could do that, and they would be translated over. Now, obviously, only the preview surface to preview surface import-export is going to be a lossless round trip. All of the others stand to have some lossiness to it. If you're going preview surface in Maya to preview surface in USD to standard surface in Maya, that should be a lossless round trip. But there are things that standard surface can represent that preview surface can't. So if you further modified that shader, then that would end up being a lossy round trip. Let's see. All right. Question numbers are going up, but my categories are emptying out here. So I'm going to have to go to the unsorted ones and see what we have. A lot of questions.
Okay, there's a blackout in Texas. Can anyone hear me?
Yeah, I can hear you, Nicola.
Doug, do you maybe want to continue with your answer, or do you want to actually say a few more things? Or
well, just to continue with what I was saying before, that OCIO v2 is in the VFX reference platform for calendar year 2021. So, we're working on adding it to Maya and other applications at Autodesk, and we're aware that other developers are also working on adding it. So we're hoping that OCIO v2 will start showing up in applications next year.
okay, if someone can help me with the questions. So that was OCIO. Do you have? Did we answer the initial list of questions regarding Unreal Engine? Yeah, we did. Yeah. We can't hear you too. Bernard, can we hear you? Can you say something?
Can you hear me now?
Yes. Did you
okay, I'm back.
Unreal Engine?
Yeah. So what was the question?
Does MaterialX have Translator to Unreal Engine?
Yeah, I answered that one. So that's basically, it's kind of work in progress between Pixar and Epic right now. So it's still kind of early days. So we'll have to wait for more information on that.
Okay. Okay, maybe I'm repeating this again. Ocio v2 in Flame. Is there anything we can discuss something about that, Doug?
Well, yeah, that's a good question. We are looking at adding OCIO v2 to Flame, and in fact, a number of the features that we added to OCIO v2 are intended to make OCIO work better for timeline-based applications. So historically, OCIO, has been mostly used in shot-based contexts. But with the new features we've added, it should be able to work better even for timeline-based applications like Flame. And I see another OCIO question. I'll take that. This is a question about paths. So the question is, can we expect absolute paths to work within OCIO config search paths on Windows? It was a huge blocker when working with configs pointing to shared network drive paths. So we did actually make some improvements, quite a few improvements to Windows with OCIO. So the search paths in particular were kind of cumbersome on Windows because it used a colon as a separator, and now the syntax has been improved so you can write Windows paths more easily. We'll have to check about absolute paths, but my understanding is that that should work well. But that's something that we'd encourage you to test, and if it's not working, please log an issue on GitHub, and we'll definitely look at that.
Yeah, someone had questions about contacting. How do we get it? I'm in a beta program. How can I contact Nicola to join LookDevX beta? I think I sent in my email there, so you can just directly contact me there. If you're in the beta, that's always easy. You can always make a comment on the beta. But I was just making my email on that David comment there. So just email me, and I'll make a list, and we're gonna go from there. Any other questions? Anyone seeing? I think we are getting close to the end.
I think we're close to the end, yeah.
Yeah. Yeah, Bill is trying to connect. I don't know what to say. I think we are pretty much done. If anyone have any quick question, yeah. So it looks like we are in the end of the session. Thank you all for joining it, joining the questions. Especially thank you everyone who presenters. So, but anyway, thanks everyone who was involved, and thank you who has actually joined here in these sessions, and keep us informed exactly what you want and how you want in our better programs. And thank you all.
Thanks for listening, everyone. We'll see you online.
Yeah.